Hi, welcome to Lesson 6, Session 2. Today we'll be modeling the relationships between adjacent place values using decimal grids and equations. So we are going to be working on pages 125 through 128 in your Ready Math workbook. So go ahead and take out your Ready Math book and turn to page 125. So the first thing we're going to do is we're going to work with some decimal grids. These are grids here. Each of these grids has a total of 100 boxes, and each grid represents a whole. Okay, so it says each decimal grid in models A, B, and C represent one whole. We're going to shade each model to show the decimal number below the model. So here we see 3.0, or this reads as 3 ones, or 3 wholes. So to shade in 3 wholes, or 3 ones, we're going to go ahead and actually shade in the entire box, all 3 of them, because we're shading in to show what 3 wholes looks like. So 3 wholes is coloring in all of those boxes. So go ahead and you can use your highlighter or your pencil, but you want to shade in the entire 3 boxes. So there you can see that we've shaded in 3 holes, plus a little extra down there at the bottom. Okay, next we're going to shade in what the value of this 3 is. Now, this 3 is right next to the decimal, but it's to the right of the decimal, which means that it is not a complete whole. It is a part of a whole. And in this case, it is showing us that it is 3/10. So we're going to shade in 3/10. So we know that 1 whole stick is equivalent to 1/10. So we need to shade in 3 of those. That's 10, or there's 2 tenths, and then there are 3/10. So here we've shaded in 3/10. And then here we're going to shade in what the value of that 3 is. And we know the value of that 3, it goes tenths, and then next is, what is it? Hundredths. That's right. So we're going to shade in 3/100ths. Well, 1 whole has 100 hundredths. So we're just going to shade in 3 of those hundredths. So here we can see 3/100ths, 3/10ths, and 3 wholes. Now it's important to notice that, remember that we talked about before, when we go from 3 over to 3/10, we're dividing by 10. When we go from 3/10 to 3/100, we're again dividing by 10. When we go from 3/100 over to 3/10, we're multiplying by 10. And when we go from 3/10 to 3 wholes, we're multiplying by 10. And so that's just important to remember, because that's going to help us when we get to our next problem. So now it says, complete 4 different equations that show relationships between the numbers shown in the models A, B, and C above. So what times 10 equals something? So let's go ahead and start with our 3/100ths, because if we're multiplying by 10, which way does our arrow go? It goes, our arrow moves to the left. So we're going to start with 3/100ths. When we multiply 3/100ths times 10, what do we get? That's right, we get 3/10. When we multiply 3/10 by 10, what do we get? 3 wholes. Now, conversely, if we start with 3 wholes and we divide by 10, what do we get? 3/10. And if we divide 3/10 by 10, what do we get? 3/100. Number 3. Finding 1/10 on a number is the same as multiplying the number by 1/10. Complete each sentence and then write the sentence as a multiplication equation. So, 3/100 is 1/10 of, or 300, what number divided by 10 is 3/100? So 3/100 is 1/10 of 3/10. And then if we're writing it as a multiplication sentence, we're going to say, we will write it as 3/100 is equal to 1/10 times 3/10. Because this is saying that we are showing what is 1/10 of 3/10. So 1/10 of 3/10 is 3/100. That means that if you divided all of this, you know what I'm even going to do here? This will even show it a little bit better. If I shade in going like this, this might even help, because let me just fill this out. All right, so now if you look at it, how many of these are in here? There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1/10 of this. So that's what this equation is showing you. 1/10 of 3/10 is 3/100. I know it's crazy to really think about, but we're going to go over this a few times, so hopefully it will make sense by the end. But it's crazy. If you think of this as being the word of, what is 1/10 of 3/10? So if we broke this into 10 parts, one part would be 3/100. Now let's go to part B. Blank is 1/10 of 3. So if we took 3 and broke it into 10 parts, what would it be? It would be 3/10. Let me show you. If we broke this into 10 parts, there's 1, there's 2, there's 3. We're going to take this 10th and add it to 2 more over here. There's 4, 5, 6, 7, 8, 9, 10. So we took this 3 and we divided it, down here, sorry. We took 3 and we want to know what is 1/10 of 3. So if we take 3 and we break it up into tenths, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How much is one section of that? It is 3/10. So 3/10 is equal to 1/10 times 3. Or 3/10 is 1/10 of 3 wholes. All right, let's go to page 126. Now we're looking on page 126. It says use the number line to show how decimal place values are related. So we are going to fill in the missing labels for the red tick marks on the number lines below. So let's do that first. So we've got 1/10 something and then 3/10. I want you to go ahead and fill out what you think each of these red ticks is. Go ahead and pause the video. All right. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then this would be 10/10. But we don't say it as 10/10. We say it as 1 whole because 10 divided by 10 would be 1. So it's 1 whole. We don't say 10/10. Now, let's go and do our red tick marks on this second line. Now, this first line here was broken up into tenths. What is this line broken up into? Do you guys know? How many of these little tick marks are there between 0 and 1 whole? I'll give you a hint. This one's 1 whole. So I'm going to draw it that way, though. All right. These are broken into hundredths. So we have, this would be 10 hundredths, 20 hundredths, 30 hundredths. That means there's 30 of these tiny little tick marks. This would be 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths, 80 hundredths, 90 hundredths, and 100 hundredths. But it, again, is 1 whole because 100 hundredths is the equivalent to 1 whole. So now we've written down, and as we can see, there's 1 whole. 1 whole is equal to 10 tenths. 10 tenths is equal to 100 hundredths. Now we're going to look at the, it says, how does the distance from 0 to 1 compare to the distance from 0 to 1/10? To the distance from 0 to 1/100th. So 1 is blank times as far from 0 as 1/10. And 1 is blank times as far as 0 from 1/100th. So let's go ahead and highlight, because I want you to see what this really looks like. So 1 from 0, 1 is that far from 0. 1/10 is this far from 0. And 1/100th is, see if I can shade it in that little, is that much from 0. So how many tenths fill up a whole number line or all the way to 1? That's right, 10. So we can say that 1 is 10 times as far from 0 as 1/10. Because 10 of these would fill all the way up. So 1/10 times 10 equals 1 whole. Now, this is the tricky one. How many times longer is this whole than this tiny little piece right here? How many of these tiny little pieces fill 1 whole? Or how many of these parts are there? That's right, 100. This one is 100 times as far from 0 as 1/100th. So this figure here is 10 times longer than this length here. And this length here is 100 times longer than this length here. Isn't that crazy? I love it. All right, now we're going to look at the connect it at the bottom at number 6 and number 7. Now, number 6, the question is, how do the decimal grids and number lines help you understand the relationship between adjacent place values in our number system? When we're talking about decimal grids, that's talking about grids like this. These are decimal grids. So how does this help us when we're looking at place value? And then this right here is an example of a number line. And how does this number line help us when we are talking about place value? So you're going to go ahead and I'm probably want to pause it. I'm going to just explain it. So if you can keep going until I stop explaining it. Let me zoom in so you can see better. So with decimal grids, that's what we're talking about from page 125. Decimal grids are a model for a number has 10 times as many squares as the model to its right. So when we're looking at those decimal grids, we know that this number to the right, that this has 10 times more than this here. And then this amount here is 10 times greater than this amount here. And then remember, I'm going to get a little tricky for a moment here. This amount here is 100 times greater than this amount here. There are 100 of these. There are 100 of these over here. So if I drew lines that went across all across at each of these black lines here, you would see that there are 100 of these in this hole here. Now, with number lines, on a number line, you see that a number is 10 times as far from 0 as it would be if its digit moved one place to the right. So, when this 1 moves one place to the right, just to the, imagine that there's an imaginary decimal point right there. If this 1 just moved to the other side of this decimal, we would get 0.1. When that decimal when this decimal moves from here and moves one place to the and the 1 moves one place to the right, that means this length here is 10 times longer than this length here. And then for here, this is going to be, that right there is 0.01. So when the 1 moves one more place to the right, it gets 10 times smaller. So let me put it back here. Now is the time for you to go ahead and pause it so that you can write all of that down for number 6. Okay, now for number 7. Number 7 says, how many times as great is the value of 1 and 5/10 than the value of 15/100? Explain. So, how much larger is 1 and 5/10 than 15/100? It has to do with that decimal. So we need to say each digit in 1 and 5/100, 1 and 5/10 is one place to the left of where it is in 15/100. When a digit moves to the left, its value is 10 times more than it was. So the answer is 10 times. So you could also say that 15/100 times 10 equals 1 and 5/10. Because each digit moved one place to the left. So this 1 moved to the left of the decimal. This 5 moved to where the 1 is. That's because we multiplied it by 10. So every time the digits move one place value, or they move 1 over to the left, so like this 1 moved to there, that 0, and this 5 moved to where the 1 was, that means that it moved over 10 times. With that, you're going to go ahead and practice. There's an exit ticket for today, and then you're going to complete pages 127 and 128 on your own. And then there is also an extra fluency page for today. So with that, I will see you soon.